Welcome back, learners. So, as we have discussed in the previous lecture, we have completed the preliminary centerline positions of the beams and columns in the AutoCAD for the given architectural plan. Okay, so you can see here, this is the preliminary, the centerline positions of the beams and column for the ground floor. This is for the first floor, and these two together will represent for the roof beam, and this will represent for the plinth beam. Now, once the grid lines or the center lines are ready, as I have already informed in the previous class, the next step is we are supposed to develop this grid line first in the given software. As I already discussed in the first lecture, that there are various commercial softwares that we can use. So in this lecturing, I am using the commercial software, what we call it as Etabs. So I'm using that. So one thing I would like to make you very clear, learners, that I'm not going to explain you in detail about all the options which are present in the software. So whichever is important for us for the design purpose, so that options I'm going to explain, and definitely when I take up the next problem, so in that time if I need some more options, definitely I'm going to use those options also. So together we will go. So now as of this, once the grid lines are ready, our next step is we are supposed to prepare the grid lines in the AutoCAD software, in the Etabs software. Now it is very clear from this diagram that whatever the dimensions I have given here, as well as whatever the dimensions I have given here, they are in feet. Okay, they are in feet. Okay, the dimensions are in feet, right? Yes, so the dimensions clearly they are in feet. Okay, yeah. Yes, okay. So they are exactly in feet. So now let us start drawing it from one to another. So I am going to consider like this only. So this will be my origin point. Therefore, this will be my x-axis and this will be my y-axis. Okay, this will be my origin point, right? This will be my origin point. So therefore, this will be my x-axis and this will be my y-axis. Okay, I hope that is very clear. Yeah. Yes. So now let us start drawing the grid lines. So this is the last line, so therefore this will be my origin. Okay. Yes. Now when I open the Etabs software, the first view that whatever you are going to see will be in this form. Okay. So now in that, when I want to start the new model, okay, when I want to start a new project here in the software, I have to go to first, I will be explaining each and every option as we move on with the modeling. I don't want to explain everything at a time. I'll be explaining very thoroughly as we move on with the modeling. Now when I open this software, so I wanted to create a new model. So therefore I will go to file, right? So you can have an option new model here, or you have an option open. For example, you are going to start the model today, and definitely we cannot complete the entire modeling sometimes in a single day. That time you can save, and next day directly you can open that file and you can start continuing the modeling. So that time we are going to use the option open. Otherwise we will go to the new model. So now since I'm starting with a new project, I'm going for the new model. So these two options, this will be default. But if you see the third option, we are supposed to give the input. So what is that input? You can see the first is display units. You can see you have an US customary, metric IS and metric MKS. When you select this and if you click on this, if you just put your cursor on this I mark, it will show you so in what units that particular software will take when you use that particular unit. You can see when I use US customary, my distance will be in feet, area will be in feet square, angles will be degree, length will be inch, area inch square, rebar area inch square. So like that it will give you. In case if I choose metric IS, then you can see that the distance will be in meter, length, absolute distance will be in meter, then the length will be in mm. So like that, so it will give you. If I choose the metric MKS, then also it will tell you what I'm using. So length mm, absolute distance meter, so like that. Now, as you know, here I'm using in feet and inches. You can see my distances are in feet and inches. Here also I wanted my distances to be in feet and inches. So therefore I'm using US customary. You can see when I use US customary, my distances will be in feet and inches. Okay, yes. Now that is the first option, that is display units. After that, next you have an option called steel section database. What do you mean by this steel section database? So you are supposed to choose that which code we are supposed to use in the software. Okay, you can see here we have various codes, AISC, like that. So you can see Australian code, then BS shapes, then Chinese, then CSSE, then core brace, then Euro, Indian, Russian, so star seismic, like that. We have different codes. So since we are working on the Indian condition, I'll be choosing the codes Indian. Once that code is decided, then your next step is we have the steel design as well as we have the concrete design. Okay, we will go to do that as we complete the model as well as after doing analysis. So for that again we are supposed to choose the code. So definitely when I'm using Indian, you can see here again you have a different steel design codes all over the world. So in India, we are using IS 800 2007. I know you are very familiar. So therefore, I'm going to choose IS 800 2007. That is for the steel design. Then what about the concrete design? For the concrete design, again, you are supposed to choose, for the concrete, it is IS 456 2000. Therefore, I'm choosing the concrete design code. Once this basic details has been specified, then you can click on OK. Okay, so what I have done, I have selected the units, whichever units I want. Then I selected the country. Then in that I selected the steel design code. Then I selected the concrete design code. So once all the specifications are given, I can give OK. Once I give OK, you can see this dialog box is going to appear. So what is this dialog box represents? This dialog box is used to specify the grid lines. I told you that you can see here in AutoCAD we have these grid lines. Now we are supposed to develop these grid lines in the Etabs software. So for that reason only we are going to use this. For that reason only we are going to use. Now again we have two options here. So this grid spacing is for the X and Y direction. Okay, this grid spacing is for the X and Y direction, that is along the horizontal axis and along the vertical axis. Whereas this is for the Z direction, that is in order to represent the heights of the building. Okay, heights of the building. Now I can directly use this. If my spacing of all the grid lines are uniform. For example, students, I'll show here. If my grid lines spacing, that is from here to here, from here to here, from here to here, from here to here, if all my grid line spacings are of same dimension, whether 2 feet, 3 feet, 5 feet, 10 feet, both in the x direction as well as here also in the y direction. That is, all these grid line spacings are of same dimension. Then I can directly use this, because you can see here the number of grid lines in the x direction. Here you are going to enter the number of grid lines, whether you need 10 or 8 or 11 or 15. Then number of grid lines in the y direction, again you will tell how much you need, 5, 10, 15, like that. Then you will give the spacing of grids in x. If all the grid spacings are same, if I give 5, then automatically your grid lines will be for a distance of 5 feet, whatever the number you have given. Similarly, if I give the spacing of grids in the y direction, if all the spacings are same, then if I give the dimension and if I give apply, then how many number of grid lines you have given, all the grid lines will have the same spacing. Okay, but if I consider this problem here, you can see the spacing between the grid lines are not same. The spacing between the grid lines are not same, they are not uniform, they are non-uniform. Here it is one dimension, here it is another dimension. Therefore, we cannot use this option. Okay. Similarly, here also it will give you the height of the buildings. So for example, number of stories. You want how many stories, whether it is a G+2 building or G+1 building, like that. Right. So you can give the typical story height, whether the height of the each story is same. Okay. Sometimes here they have given the option typical story height and bottom story height. Why is it so? Nowadays, you can see here, learners, in the metropolitan cities, usually in all the commercial buildings, they are going to provide the basement. Wherever the basement is provided, usually the height of that particular story is less compared to the other stories, because you are not going to utilize that particular story for the public purpose, it is just for the parking purpose. Therefore, usually they keep that story height less. Okay, so that's the reason we can give the bottom story height specifically separately, and typical story heights, that is after the bottom, whatever the story heights are there, that you can give. Again, this option can be given only if all the stories which is present above the basements are same. For example, you have a basement or a ground story of uh, say for example 7 feet. After that, if all the stories are of 10 feet, I can use this. If one story is 10 feet, another story is 9 feet or 8 feet, like that, again if changes are there, we cannot use. So therefore, this option and this option is applicable when my story heights and my grid line spacings are uniform. If my story heights and grid line spacings are not uniform, we have an option here called custom grid spacing. Here also, here also. Now, for the sake of simplicity, here let us assume that my bottom story height and the typical story heights, everything same, but grid spacings are not same. So therefore, I can give, it is a G+1 building, that is ground plus 1. Therefore, I can give the number of stories as 2. Okay. So whereas the typical story height usually we keep between 10 to 12 feet. So we will take up as 10 feet. Even the bottom is also here same 10 feet, because there is no any basement here. So therefore I can give this dimension for the building heights. Whereas this is not possible, because as you have seen in the AutoCAD here, my spacing of grid lines in X and Y directions are not uniform. Therefore, I will go for the custom grid spacing. So I will select this custom grid spacing and I will give you specify the data for the grid lines. I will give edit grid data. Okay, I'll give you edit grid data. Now, whatever you change here, so it will be shown here in the form of diagram. Now you can see that you have again two options: display grid data as ordinates, display grid data as spacing. What do you mean by this? I'll explain here. If I choose the display grid data as ordinates, you can see here this is X grid data, that is A, B, C, D, that is like this in the X direction, whereas this is Y grid data 1, 2, 3, 4, that is in the Y direction. Okay, so first I'll explain you what do you mean by this display grid data as ordinates. Okay, so when I choose display grid data as ordinates, you can see here this is my first ordinate, that is my origin, that will be 0, 0, right? So now my second ordinate will be this one, so that will be 2 feet 5 inch, 0. Okay, 2 feet 5 inch, 0. Now when it comes here, so for that, now what I have to do, I have to give, so it is 8 feet 8 inches 5 inches, so it becomes 13 inch. 13 inch means 1 feet 1 inch. So therefore if I add, it is 9 feet plus 2, 11 feet plus 1, 13, 11 plus 1, 12, 12 feet 1 inches. That means here I have to give 12 feet 1 inches. Then when it comes here, for that I have to add 6 inches. Therefore it becomes 12 feet 1 inch plus 6 inch, that is 12 feet 7 inch. Now for that again I will add, so it becomes, so 12 plus 4, that is 16. So like that I will be adding, that is giving the grid spacing in the form of ordinates. That is also one way. The another way is you can display the grid lines in the form of spacing. When I give spacing, it is directly 0, then the second line spacing is 2.5, then the next line spacing is 9 feet 8 inch, then next grid line spacing is 4 feet 5 inch. So like that, what you can do, you can give the spacing, you can give the ordinates as spacings. Okay, so that is another way. Okay, you can use any of the method, that is another way. Okay, so you can use any of the method, no doubt you can use any of the method, the choice is left to us. Okay, yes. So now compared to ordinates, the spacing with giving the grid lines with respect to the spacing is much more easier. Okay, giving the spacing with respect to the grid lines, this option is much more easier. Okay, yes. So you can, now you understood A, B, C, D will represent the grid spacing in the X direction, whereas 1, 2, 3, 4 will give the grid spacing in the horizontal direction. And you may ask this, what is this bubble size and grid color? So this bubble size and grid color, that you can change this. If you want, you can make to some yellow color, or you can make to some red color. The option is given to you like this. And this bubble size also you can vary. It is given 60 inches. I can make it 40 inches also. Again, it is my wish. Okay, I can I can make it 40 inches. So this bubble dimensions will change. Right? Yes, I hope you understood. Right? Okay. So once this everything, whatever it has done, I clearly told you that I don't want the display grid data as ordinates. I'm going for the display grid data as spacing. Yes, now I made it as spacing. Now first we will go to X. Now when I go to X, you can see here, You can see here. What I'm going to do is first I'll delete everything. Okay, I'll delete so that it will be very easy for me. So first I will add, so this grid I will give it as A, so the spacing will be 0. Then I will give add, so that will be B, right? So now for that the next spacing is 2 feet 5 inch. I can give the spacing 2 feet 5 inches. Okay, yeah, so it is 2 feet 5 inches. Okay, what is the spacing? 2 feet 5 inches. Yes, it has taken like this. This is 2 feet 5 inch. Now, after that 2 feet 5 inches, it is 9 feet 8 inches. So therefore, this spacing will be 9 feet 8 inches. Okay, so it will be 9 feet 8 inches. Then after 9 feet 8 inches, so you have here one more, that is 6 inch. Okay, that is a small 6 inch. Okay, so it is 6 inches. Yeah, it is 6. Okay, that is 6. Then after 6 you have 4 feet 5 inches. This one 4 feet 5 inches. So this 4 feet 5 inches. Okay, 4 feet 5 inches. Okay, so if you want to convert, I think this will not take like this, so I let me enter the correct value. It is 6 inches. It means I am supposed to convert it to feet, right? You know 1 feet is 12 inches. Therefore if I divide 6 by 12, it will give you 0.5. So it means I have to enter 0.5, right? Yeah, yes, so I have to enter 0.5, that is 0.5 inches. It's very small. Then 4 feet 5 inches. Then I have added 2 feet 4 inches. Okay, so it is 2 feet 4 inches. Okay, 2 feet 4 inches. Yes, so 2 feet 4 inches, that is 4 by 12 plus 2. Yes, 2 feet 4 inches. Then after this 2 feet 4 inches, you have one more 4 feet. I can give this as 4 feet. Okay, 4 feet. Sorry, 4 feet, or you can, yeah. So it is 2 feet, then it is 4 feet. Yeah, 4 feet. Then after 4 feet, you can have 5 feet 5 inches. So that will be 5 feet 5 inches. Okay, 5 feet 5 inches, 5 feet 5 inches. Okay, 5 feet 5 inches. Then after that 5 feet 5 inches, I have 1 feet 8 inches. I have 1 feet 8 inches. Okay, 1 feet 8 inches. Okay, 1 feet 8 inches. Okay, 1 feet 8 inches. So after 1 feet 8 inches, the last is you have 11 inch. Okay, you have 11 inch. You have 11 inches. Okay, so that is 11 means 0.916. 0.916 feet. Okay, yes. So therefore, this last you can delete it. Sorry, 0.916 feet. Okay, yes, 0.916 feet. Right. So therefore, if you add it, if you calculate what are the total lines, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9 and 10. You have totally 10 lines. You can see how much you have. So started from 0 here. Okay, started from 0. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 8, 9. So exactly 0. You can check here. So 0, that is first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you see the spacing, you have only 9 spacing exactly. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 spacings exactly, here also 9 spacing. Okay, yes. So in the same manner, even I have to give this in the y direction also, right? So that we will see in the next video. Okay, that we will see in the next video. Thank you, students.